Okay, so let's find some limits from a graph. Okay, for number A, this says the limit as x approaches -1, and you see how there's a superscript and it says plus. What this means is that they're asking us what is the y value when x approaches -1 from the right. When it says plus, you look from the right and go to that point. And if it says to the left over here, which we'll get to, if it says 1 and then a minus as superscript, we're going to be looking at it from the left. And I'll show you what that means. So here it says x approaches -1 from the right. So first we find -1, and -1 is over here. And now, to find the limit, we just see if there's a graph and if it goes up to that point, and it doesn't matter if it's a hole or a point. All we have to know is that, is there a graph going up to that point? And here there is. And now we just see what y value corresponds to that, and that is 1. So that's why this is going to be 1. And now let's look at question B. Limit as x approaches 2 in f of x. Oh, by the way, this is the graph of f of x. So now, when they don't give a superscript as plus or minus, what they're asking is, what is the limit when x approaches 2 from both sides? So not just from the right or the left, we're looking at it from both sides. So here, this is 2, and you see there is a graph that approaches 2 from the right and the left, and that approaches 1 right here. Now see, we have the limit as f of x, limit as x approaches -1 from the left. As you see, there's a superscript from the left because of the negative. So we look at -1 and see what the limit is as it's coming from the left. But even though it's one over here, there's no graph that's coming from the left, as the most left point is -1, and there's nothing beyond that. So since there's no graph, there's no limit to get to. So that's why the limit does not exist. So when you have a limit and you see that it doesn't exist, you just write DNE for it does not exist. Now we find the limit as x approaches 1 from the left. So 1 is over here, and we have to see if there's a graph that's coming from the left. And you see there's a straight line that goes up to 1 from the left, and that is 2. And now, let's see what the limit is as x approaches 1 from the right. So now, it's going to be different, because here this approaches 1 from the left, and here this approaches 1 from the right. So when it approaches 1 from the right, it's going to get to 1. And now, limit as x approaches 1 from both sides. So from the right side, it approaches 1, and from the left side, but it approaches 1. But the difference is that both of these points are at different places at the y-axis. Since this is at 1 and this is 2, they don't match each other. If there were to be a limit at 1, both of these points should come at 1 or come at 2. So that's why it does not exist. The definition of a limit means that when x approaches a certain value, from the left and right side, they should both be equal. And in this case, it's not. From the right, it's 1, and from the left, it's 2. So here, limit as x approaches 0 from the right. So from the right, we just look at the graph, and it goes down all the way to 0. So we can just say the limit is 0. Even if it said from the left, it would still be 0, because they both match at the same point. Okay, so this is our second graph we have. So question A asks us, find the limit as x approaches 1 from the right in f of x. So let's find 1. 1 is right here, and they're saying find the limit as it approaches from the right. So this is our graph, and we go to the right, and we get to 1, and even though there's a hole, it approaches at 2. And it doesn't matter if there's a hole, because when we say limit, we're not actually getting to that point. We're getting infinitely close, but it'll never get to that point. It's sort of like an asymptote where you'll get infinitely close to the asymptote, but you'll never be able to touch it. So B asks us, find the limit as x approaches 1 from the left. So this time, we find 1, and the graph coming from the left, it points all the way down to -1, even though there's a hole, we ignore that. Now C, we have limit as x approaches 1, in f of x. So 1, there's a graph that's coming from the left and it's coming from the right. But the issue here is that when it comes from the left, it approaches -1. And when it comes from the right, it gets to 2. So even though there's limit coming from both sides, they're not equal. So since they're not equal, the limit does not exist. Okay, just remember that. If they asked to find the limit as x approaches 0, it would work because the graph gets to 0 at the same point. Now D asks us f of 1. So there's no limit or anything like that. So just finding f of 1. So even though there's a hole here, we still have an answer because f of 1 is really 1 because there's a solid dot here. So the answer is 1. And it's not these holes because when there's a hole, what it's really saying is that the graph gets to infinitely close to that point, but there's not an actual point over here. So that's why f1 equals 1. Now for E, we have limit as x approaches 2 from the right. So x approaches 2 from the right gets to 3 because there's a graph over here and it approaches to 2 and it gets to 3. And now F, we have limit as x approaches 2 from the left. Even though it's coming from the left, it will still be the same answer because they're both intersecting at the same point. So it's 3 again. And now limit as x approaches 2, this will be 3 again because the definition of a limit, it has to approach the same point from the both sides and be equal. And you see how when it approaches from the left, it gets to 3. And when it approaches from the right, it also gets to 3. So we can say the limit as x approaches 2 is 3. Now they're asking us find f of 2. So f of 2, again, is 3. They're not asking us for limit, just finding what is the y value when x equals 2, which is 3.